Now, stress strain graph. How this experiment, of course you have to do experiment, then only you will get data. Those data you will plot along y-axis and x-axis and get a graph. On y-axis we will plot stress, which is, again don't forget, internal force per unit area, and here we will plot strain. Now, how this experiment is performed, listen carefully. They will take the wire on whom you want to do this experiment. They will clamp one end, and on the other end they will pull with uniform speed with the help of some machinery. Human being cannot do with that much efficiency, right? So you will use some machinery and pull this slowly with uniform speed. Matlab, every second maybe they will increase by 1 millimeter, or maybe 0.1 millimeter they will increase. There they will put some sensors to measure the force required to pull this uniformly, because every time you will pull this, a tension force will be developed, and if you leave the applied force, what will happen? It will go back. So what you have to do to make sure it moves uniformly, apply same force as tension force, and then plot stress here, strain here. Got the idea? So they will pull the rod uniformly, and to do that, how much force they are using, that they can calculate with the help of sensors attached there. So force per unit area will give stress, strain is delta L by L. Now, initially what they find? Initially they find that the graph goes linearly up to some point. What does that mean? From O to A, stress and strain are what? Directly proportional. So from O to A, stress is directly proportional to strain, meaning Hooke's law is obeyed. Hooke's law holds in this region. What does that mean actually is, let's say for 1 millimeter extension you needed 100 Newton force. Then for next 1 millimeter again you will need 100 Newton. So that is what this part says, and that is expected. It's like spring force only. The more is X, the more is spring force. So the bonds between the atoms will get stretched like a spring, and the more it gets stretched, the more force it will try to bring it back. So you will also have to apply same force. Therefore, the force per unit area increases, stress increases. However, once you cross this point A is called proportionality limit. Proportionality limit. Once you cross this point, the graph slightly dips. What does that mean? Can you guess? Now, to create the same extension, you actually need less force. So, no more proportional now. Or, by applying same force like before, you are able to extend the wire much more. So, after you cross this proportionality point, the wire in a way becomes in a way loose kind of thing inside. And the good news is, till this point, if you bring the stress to 0, the strain also goes back to 0. Matlab, till that point our wire is elastic. So B is called elastic point, or sometimes it is called yield point. Yield matlab to give. Because beyond this point, the wire will start giving up. What do you mean by giving up, sir? Yield means what? Yield. When I stand on this hard floor, I say the floor does not yield. But if you stand on a soft, sandy floor, we say it yields, it gives, it gets depressed. Understood? So after this point, no, our wire will now start giving up, meaning it will start becoming really, really long. For small forces also, the strain will be huge. However, the stress still increases, but before, if you wanted to create this much strain, and you used this much stress. Later, once you cross this elastic point, to create the same strain, you need very, very small stress. As I told, the wires is finding new ways to become more and more longer easily. In fact, what happens, inside the wire, there are some irregularities. The atoms are not periodically arranged in a nice way. There will be some dislocations which are like defects. For example, suppose you have a carpet and you create a hump in one of the place, hump. So that hump is like dislocation in the crystal. In an otherwise nice looking crystal, this hump is creating a kind of distortion. Now what this hump does, look carefully. Suppose I want to shift the whole carpet that side. Okay, now if you pull the whole carpet against friction, you have to do you have to apply a lot of force. But if hump is there, what you can do? Just push the hump only. This hump will go to this part, then this hump will go to that part, and when that hump will reach the end and you push that one, the whole thing has shifted slightly that side. So the presence of these dislocations inside the wire allows lesser forces also to make the wire stretch easily. Even lesser increase in forces, I should say, will make the wire stretch easily compared to before. Understood? So this is called your plastic region. And once those dislocations are there, the wire will now not come back. The plane of atoms will slide past one another and they will become permanently changed. Little bit they may come back, but they will not come back like within the elastic limit. So this region is called elastic region and this region is called plastic region. Meaning if you are at this point C, let's say, how much stress you have, this much, how much strain, this much. Now you bring the stress to 0, strain will not come to 0. This much permanent strain will be left. That means your wire will go back in this kind of line instead of coming this way. So this is called permanent set. What set? Permanent set. Meaning this much of permanent change is left in the wire because you have gone beyond the what limit? Elastic limit. Then a time comes when the stress becomes maximum as given by NCERT graph, and that point is called ultimate tensile strength. Please write the spelling, ultimate tensile strength. So the stress corresponding to that point is written as sigma u, and the stress corresponding to this point B, which was yield point, is called sigma y. And after that NCERT shows the graph dipping down, and somewhere here at this stress the wire will break. So E is called your fracture point. Now students, if these points are very close to each other, if B, D, E are very close to each other, if D and E are very close to each other, if DE is very short, what does it mean? After you cross the maximum stress, or once your strain has reached this much, from there to break, if this is very small, you need only small delta L to break, meaning it is very brittle. And if this length is quite long, then you need large change in length before it breaks. So material can become longer and still it will not break. So that is called what? Ductile. Now my only doubt is, once you reach maximum stress, why the graph is coming down? Because I felt when the wire breaks, the stress should be actually maximum when it actually breaks. To be honest, the true stress acting in the wire during fracture point is actually more than this also. That means actual graph should go like this. But why NCERT made graph down? Because NCERT never told that the stress that they have plotted, this stress that they have plotted in the graph is not the true stress, guys. It is called engineering stress. engineering stress is a name. What can I do? It's nothing. It is just the force which is pulling the wire. The sensors I told no are measuring force needed to pull the wire uniformly. It is that force only, but it is divided by original area, not the actual area of the wire. Original area. Whereas true stress will be F divided by actual area. And when you cross this point D, the maximum stress point, the wire becomes so thin that at some points in the wire becomes so thin that neck is formed. What is formed? Neck. In physics or engineering, they call it necking. That means the wire looks something like this. So this area, the true area, becomes exceedingly small. So this becomes exceedingly small. If the wire became very thin, then the force needed to pull it will become now less. Think 5 fingers are there getting pulled. To stretch this much, you need some force. Now only 2 fingers. So the load carrying capacity of 2 fingers will be less than 5 fingers. Isn't it? So this F which is needed to make it stretch, that F also decreases drastically due to this necking. However, though this decreases even more faster than this. So overall true stress increases. So if you had plotted the true stress at that neck, the graph would have gone like this. However, NCERT plots which graph? Engineering stress graph. In engineering stress, what happens? This force, though I told, decreases. So this decreases, and here what they are plotting? Original area, which is fixed. Original area which it had before they stretched. So this original area is fixed. This started decreasing. So what will happen to engineering stress? Decreases. That's why the graph comes down. Understood?